Hi all, this is Priyadashni working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to look into the topic deadlock in operating systems. So the main objective of this lecture is deadlock. So we will see what is system model, the characterization of deadlock, the methods to handle deadlock. So there are four different methods. One is deadlock prevention, deadlock avoidance, deadlock detection and recovery from deadlock. So we are going to see all this in the coming videos. So what is a system model? So a system model is nothing but this. Whenever we talk, generally we talk about a system. The system will be consisting of the finite number of resources. So here the finite number of resources is being represented as R1, R2, etc. up to Rm. So what are the resources? So resources might be anything like your CPU or your printer or some other IO devices like monitor system, whatever it is. So those are called as systems, the resources. So generally a system consists of a finite number of resource types. Suppose if we take a printer may be limited to 5 resources. So that is called a resource. So printer is a resource, and remember the 5 I told you, no, 5 printers are there. So those are called as instances. So that is called the instances of that particular resource type. So a system contains a finite number of resource types to be distributed among all other competing processes. So this resources can be a file, an input output, a CPU, memory, whatever it is. So I told you about the instances of these resources. So generally a system model has a process is that it has to utilize a resource in 3 ways. So the first utilization is called as a request. So whenever a process needs some resources, it has to put a request to the system. If the resource is free, the request will be granted. Otherwise, it will be made to wait to acquire that particular resource. The next step is called the use. Suppose if the request made to the resource is available, that request would be granted. Then the process is allowed to use that resource to complete its operation. After completing its operation, the third step is called the release. So the process has to release the resource. So first request has to be made, use until its operation has been completed, and then after completing its execution, it has to release the resource for other competing process to execute. So this is the general typical system model. Now let's see what is a deadlock. So in short, deadlock is nothing but it is a indefinite blocking of different processes. We call it as a deadlock. So deadlock can be defined as a permanent blocking of processes by some other processes, or the communicating processes is called a deadlock. Indefinite blocking of process is called a deadlock. So let's see an example. So here is a traffic deadlock in an everyday. This traffic deadlock is an everyday example of a deadlock situation. So consider here a car is there. So when a car, or you can take a train. So when a train is approaching each other at a crossing, both may stall, or that is a full stop, or neither shall start. So only one train can enter into the thing. If some other train also is in that way, then either both the trains would stall, that is both the trains will stop, no other train is made to start up. So this condition is called the deadlock situation. So this is called the indefinite blocking of process. We may not know when this train will move and leave other trains to pass in that particular stage is called the deadlock. So what are the characterizations of deadlock? So deadlocks, the characterization of deadlock is of four things: mutual exclusion, hold and wait, no preemption, circular wait. So what is mutual exclusion? Mutual exclusion is nothing but only one process should be executed at a particular time. Hold and wait. So a process should hold at least one resource and should wait for an additional request is called hold and wait characterization. The next one is called no preemption, that is forceful termination will not be done. The last characterization is called the circular wait. So P0 resource is waiting for P1, P1 is waiting to P2, P2 is waiting P3, P3 is waiting for P4 and P4 is waiting for P0. So this is called the circular wait characterization. So a deadlock will arise if four conditions hold simultaneously in a system. Then we say definitely there is a deadlock in the system.